All right, everyone. It's 1:30. Welcome to this Container Days talk on clean infrastructure as code. I'm super excited. I'm quite a bit nervous because my technical setup with this remote setting is super new. All right, everyone. It's 1:30. So let's hope that the technical setup works. Excellent. Okay, then let's dive into the slides. Now, as you can see from the title, I kind of have a catchy title, and it's about clean infrastructure as code. And if you are a software engineer like I am, or a software architect, then you might know these books here on clean code and clean architecture by Robert C. Martin. And I would argue for today and for the next 35 minutes that many of the principles on clean code and clean architecture that are presented in those two books, well, I would say they also apply to infrastructure code. Now, having said that, I think the reality especially on infrastructure code looks quite different. It doesn't look that clean, right? It's more this type of picture here. It's many broken windows, it's no modular structure, tests are missing, no components there, highly tangled design. Just get the infrastructure code working. As long as the infrastructure works, everything's fine, we're done. What makes things even worse is, in my opinion, and I've seen many teams struggle with that trial and error seems to be the predominant approach to get your infrastructure code up and running. All right, so what does the development loop look like? Well, you write some code, you try to run the code, well, it doesn't work. Well, you write some more code, or you change the code, you try to run the code again, well, and you write some more code, and at some point, suddenly the code begins to run, and then you're done. And that doesn't really matter example, consider writing a Docker file, right? You write a Docker file, well, you do the good old Docker build and Docker run. Either of those two commands will fail. Well, you do a few modifications to your Docker file. You then do Docker build, Docker run again. Well, let's see if everything works. No, it doesn't. I change the Docker file again, and at some point it runs. I commit my changes, I push my changes, and that's about it. And who knows what comes next? Probably pretty much the same here with all good old Kubernetes YAML, right? I write those manifests for my deployment or for my service or whatever. I hit kubectl apply. Let's see if things work. Well, they don't. I change it again. I do the same loop again. kubectl apply. No, it doesn't. Change the YAML again. And at some point, my Kubernetes manifests start to work. I commit them. I push them. I'm done. Infrastructure works. And pretty much the same here with Terraform, right? The command is different, but the flow is similar, right? You do Terraform apply, well, it doesn't. You change your Terraform definitions, you add a few things, you hit apply again, and you do that continuously until Terraform apply works. Now, I know this is a bit exaggerated, and it's up to you to decide if you kind of follow this trial and error approach, or maybe sometimes, or maybe some people on your team follow that approach, right? I don't want to blame anyone. It's up to you to decide on which level you're here. And we could ask ourselves, what is the reason? What are the usual suspects? And in my opinion, it's always the same excuses, right? Always the same excuses, the same myths, and the same reasons that have always been there for writing bad code and smelly code. And the infrastructure code is not any different here. Now, the first reason is, in my opinion, the only valid one, but there are ways out of this reason, or out of this excuse. And I think especially young and inexperienced team, they suffer from this high cognitive load and maybe some missing know-how within their teams. So, if you're a young team and you start fresh, right, you have all your heads into this, getting the features right you need to implement and doing the technical implementation. And we all know that the responsibilities of modern DevOps teams, they have changed quite significantly. Now suddenly those teams, they have to care for the infrastructure as well. And now they suddenly have loads of new tools and loads of new technologies that they have to cope with as well, right? And that is kind of the main problem. But the way out of this, well, dilemma is pretty easy. Go to conference like ContainerDays, watch talks like this one here, maybe do some education on your team so that the team does not suffer from this high cognitive load again. The second one, and that's kind of also true, that if you want to do quality assurance on infrastructure as code, things are slightly different than it used to be with, writing plain business code, because you have a high infrastructure complexity and of course costs associated with this one. And if you look at declarative tools like Terraform, the problem is that testing is not that easy. You need to have an integrative test approach. You need some infrastructure. You need to spin up the environment to know if your Terraform code, for example, works or doesn't. And the infrastructure cost, in all fairness, I mean, we're in the cloud, spinning up a few instances in the cloud, and after the test, tearing them down again will not cost you that much money. It's just the investment on, writing the code and writing the tests and doing those integration tests. Now, unfortunately, for the last two things here, for the last two reasons, the feature greed of missing awareness of your product owners, or those urgent deadlines, or those unrealistic plans, I mean, those are like, those excuses for bad code quality for ages, for the last 25, 30, probably 40 years, right? And, well, it's a people thing. Maybe talk to your product owner, for example, and make sure that those ops and infrastructure related tasks and acceptance criteria, that they are inside the user story, that those acceptance criteria are in there. So make your product owners aware of this. This is the only thing you can really do, right? And get those things in your definition of done, so that next time you are allocated enough time to do things properly, especially on the infrastructure code. And yeah, well, deadlines are always urgent, and unrealistic plans, they're always there. Well, do some planning and try to make the best of it. Now you might think, who's this guy actually? Why is he talking about this infrastructure code? What experience does he have with that? Now, this is me here. I'm Leander. I'm a principal software architect working for Coavia. And if you might wonder, what does the Q stand for? Well, the Q stands for quality. So I'm really into writing quality code. We as a company are really into writing, the best quality code for digital products for our customers. We got our headquarters in Munich. My prime customer is this large automotive company that is located in Munich, for example, while we have other companies like German Telekom, for example, or the Allianz Insurance, or Aldi, for example. Unfortunately, I can't be in Hamburg today, so I'm here in my studio in my hometown, Rosenheim. And it happens to be that here in Rosenheim, there is a University of Applied Sciences where I studied computer science a long time ago. And nowadays, I am a part-time lecturer for software quality assurance. And well, the last semester and, talking to students and also my current projects, they kind of made me think about this. How can we do quality assurance? How can we write clean infrastructure as code? They made me think a lot about that topic, and that's what this talk today will be about. Now, I don't want to give you a lecture about software quality assurance, okay? I assure you. I want to show you some tools. I want to give you best practices and so on and so forth. But there's one slide I want to show you, and this is kind of crucial when you think about software product quality. And this is this one here, okay? And I would argue that the architecture and the code of our infrastructure also needs to address many of those 8 criteria for good software quality. So make sure, if you have never heard about software quality, make sure you have a look at the ISO norm. It's 25010 about software product quality. And well, that basically mentions all those ilities, right? Like maintainability. That's kind of the main quality attribute we software engineers usually like to think about. So maintainability, you talk about modularity and reusability and modifiability and also testability, right? And I would say maintainability is a big thing when you talk about infrastructure code. Efficiency, portability, compatibility, suitability, usability, so many more of the ilities. And I would say security, for example, is a thing. We have the year 2021. Security is a prime feature, is a prime quality attribute. And the infrastructure also needs to take care of this. Same for the reliability, right? We're building cloud native applications. Cloud native applications run on infrastructure. And you want reliable infrastructure so that your cloud native application runs reliably. So you need to take care of availability. You need to take care of fault tolerance or recoverability on an infrastructure level. And nowadays, it's all cloud infrastructure. What do? We write infrastructure as code. Name it the Terraform files, for example, or the good old Kubernetes manifests you need to deploy your application to the cluster. This code you write, that needs to address those criteria in the early stages already. Now let's talk about some of those principles that many people of you might have heard already. The first thing is KISS, right? Stands for keep it simple and stupid. And this is all about complexity. And the big reason behind this is really simple, right? Complex things and overly complex things and unnecessarily complex things, they're hard to maintain. It's as easy as that. So the simpler you make your code, the easier life is, the easier the maintainability of that code is. So refrain from, implementing features on the infrastructure level you might not need or you may need in the future, but you don't know yet, okay? Have a look at the slide deck I mentioned here by Neil Ford from ThoughtWorks. It's about emergent design and evolutionary architecture. Now, this slide deck mainly talks about, application architecture. But I would say that the idea of emergent design and the idea of evolutionary architecture also applies to the infrastructure, okay? Do those things at the moment that are required, that, get you in the next iteration. Don't add additional complexity that is not required at the moment, and then evolve your infrastructure as the application evolves. So keep your infrastructure code simple and stupid. Rule number 1. DRY. You maybe heard of DRY. Stands for don't repeat yourself. Also here, this is kind of every software engineer would say, repeating yourself is not a good thing, right? You have the same piece of information or the same logic. If you have that distributed throughout the code base, then you have a bit of a maintenance headache, right? Because if you had to make changes to that logic, you have to make sure that you make that change to all the places or to all the redundant places you have the same piece of logic or knowledge, right? So in a way, repeating yourself is definitely not a good thing. Now, having said that, it can go in the opposite direction as well. I find many teams, and especially advanced developers, they refactor out all the redundancies, no matter what, right? Be it 2 lines of code redundant, it's been refactored. And that kind of has a bit of a reverse effect on the maintainability and on the understandability of the code base, unfortunately, because now it's super tangled and it's very hard to grasp what a piece of code is doing. So my advice would be, yes, adhere to the don't repeat yourself principle, but with caution, okay? Take that serious. Not every 2 lines of code are worth of refracting out. So make a wise decision on that one. Now, separation of concerns. Now, separations of concerns is, have things decoupled. Introduce modules, introduce layers, introduce components that take care of a specific aspect of the infrastructure, Maybe have a module that spins up the whole networking layer. Maybe have a module that takes care of all the security, or maybe have a component that kind of takes care of all the diagnosability and all those cross-cutting concerns, okay? So think in layers, think in components, think in modules, represent those modules and layers in your infrastructure code, and make sure that those modules, layers, and components, they should have loose coupling, and inside each module should have a high cohesion, right? So that not only applies to normal business application code, I would say you also have to make sure on the Terraform level or maybe on the Kubernetes level that you get your layering right, your modular structure right, to properly separate individual concerns within your infrastructure as well. Now, last but not least, well, you see this principle is called SOLID, and the SOLID is actually let's say an acronym made up of the single responsibility principle, open close principle, Liskov, interface segregation principle, and dependency inversion principle. Now, not all of them, I would say, apply to infrastructure code, but take interface segregation, for example. Just a time ago, I wanted to use a super highly sophisticated AWS Terraform module to spin up an RDS instance. Now, this module was super powerful, and the interface of that module is kind of made up of all the variables that are required to kind of parameterize the module. Now, the interface definition and the amount of variables for that module, I don't know, 75, maybe 70. So the interface of that module is way too big, in my opinion. It would have been better to have like smaller interfaces and smaller, more tailor-made modules instead. And that's basically what I then did to abstract away this huge module. Because if you have this large interface, that has two major downsides if you write the code. The first thing is it's super hard to understand, right? So this RDS module, that can spin up pretty much any combination or any configuration of Amazon RDS you can think of. So serverless Postgre RDS or a plain RDS cluster hosted on EC2. And depending on which configuration you want, you need to make sure and you need to know which of these parameters are required, which parameters cannot be set in combination with another one. So that makes, first up, the module very hard to use for your users. And secondly, I would say having a super large interface, a very generic interface, makes it very hard to maintain. So also here, single responsibility. Have Terraform modules, for example, that do one thing, that spin up an Aurora database and not all the rest. So very specific one, and then make sure that the interface of those modules, for example, have a very small but then tailor-made and very specific use case specific interface. That's important for maintainable code and maintainable infrastructure code. Now, last but not least, here are a few more clean code principles. I will not go through all of them, but this is kind of a condensed version of what you can read in the one book. The first thing I would say in the general rules is, first up, follow standard conventions, right? So if there are a lot of conventions how to write good Terraform code, so you should stick to these. That's the first thing. But also, I mean, we're all humans, we can make mistakes. In order to follow those standard conventions, I would say from a quality aspect and from a quality assurance perspective, you should then also check that the standards, that you adhere to the standards, that the code is conform to those standards. So you need some form of static analysis, for example. You need some form of linter, some formatter. Maybe you add some tests so that you stick to those conventions. We already talked about keep it simple and stupid. Simpler is always better. It reduces this complexity as much as possible. Think about the naming, right? Everything that applies to your business code applies to a clean code on an infrastructure level. Don't be funny. Don't choose funny names. Choose descriptive names that are unambiguous. Use pronounceable names, names that can be that you can search for. Be consistent. Yeah, right. If you have a large code base, it is important that you are consistent. That if you've decided to do something a certain way, you should always do it that way, right? Use explanatory variables, avoid negative conditionals. So there is a lot about understandability. Now, people might say, well, for understandability, I add comments. Well, be careful with those. Always try to explain yourself in code and not necessarily in comments. Don't be redundant. Don't add obvious noise. This is a Terraform definition. Yes, I know this is a Terraform definition. So yeah, this is just noise. Don't comment out code. Just remove it, right? Otherwise, it's technical debt. Maybe use comments as a warning of consequences or something like that. Look at the source code. General rules. Don't break indentation. Keep the lines short. Watch for the white spaces, that everything is indented properly, formatted properly, things like that. When you design things, prevent over-configurability. I told you about this RDS module. I mean, 75 configuration parameters. Who on earth needs those, right? So this is over-configurability. Be careful with that. Use dependency injection. And yes, you can use dependency injection on a Terraform infrastructure code level. You just need to know the tools that can help you with that. Have a look at the data structure, small number of variables, and yes, have tests, right? Have tests at the infrastructure level. That is really important. Now, before we dive into the code, two more things. First up, think about the conceptual architecture of the infrastructure and think that first before you write the first line of code. Because the conceptual architecture of the infrastructure, it will have a significant impact on the structure of your source code and the way you organize it into Git repositories, for example. So those are those obvious things like, okay, you need to think about ahead, okay, I have this product and this product requires infrastructure. So what cloud regions do we need to run in? Which parts of my infrastructure in the system needs to be replicated and what is only in one region, for example? Well, you need to think ahead of how do we model environments, right? So think of a dev environment, int environment, prod environment. How do you do that? You do that on a VPC level? Well, possible. Or maybe do that on a Kubernetes namespace level. Also possible, right? So many choices. Make those choices in advance. Which layers and components are required, right? What layers and components are kind of common to everything? Do I need a network component or a networking layer? Do I need a security layer? Do I need a diagnosability module and layer? And what are the dependencies between those layers and between those components? And finally, once you've done all that homework, and it doesn't need to be a lot, right? A few diagrams, as you see here, those are kind of a few diagrams I've drawn in early phases of my projects. Well, they will then determine the structure of the Git repositories and the source code to represent those layers and components. So that's one thing you should think ahead before you write the first line of code. And another thing that needs to be done beforehand, well, you need to decide on the tools and frameworks you intend to use for your infrastructure code. And that can be done on multiple levels, right? Of course, you need to do that on an infrastructure as a service level, right? So you need to choose a cloud provider, well, AWS in that case, and then you should kind of write down and make sure, okay, what are the required services I want to consume and that I require to build my base infrastructure, right? Then next up, kind of the cluster as a service or container as a service layer, right? So in our case, we have chosen to go with them as an EKS. You might go for a fully managed solution, or might choose Kubernetes, or maybe choose a conveyor. Many options here, and then decide and then say, okay, we go with them as an EKS. And with those services, then of course come the tools and frameworks. So maybe on that bottom layer, you decide, well, I want Terraform, I want TerraGrunt to do some, dry principle things. I show you in a second, that is a really cool framework. Maybe you want to do some CI stuff and some peer review model, then maybe you choose a system like, or a framework like Atlantis to then have a peer review process for your Terraform files. And then next layer up, a platform as a service. So how do you deploy software to your Kubernetes cluster? Do you choose Helm? What is your GitOps workflow? Do you use Argo CD or you go with Flux? Do I need a service mesh? Do I need seal secrets? Maybe you have a look at Crossplane, Operator SDK. So all those, application layer level infrastructure components. So those application specific software infrastructure that your application then needs. And then last but not least, that's kind of then the layer where most of our software engineers are working at, is like, okay, how do we build actually our applications? But at those bottom, let's say 3 layers, you have to make the right decisions, because that is, well, rather crucial on how do you then do the quality assurance? Which things does my team need to know? And well, maybe I do some education of my teammates with those tools, because this is kind of the daily stack everyone on the team needs to work with and needs to be confident with, right? All right. Now, quick look on the watch. Bit time left. Now, I have quite a few demos and examples. Please make sure, have a look at this Git repository here. It's on my private GitHub account at the moment. It's called Clean Infrastructure as Code, MIT licensed, but it's just a few demos and showcases to get you going with that one. So let's quickly go to Visual Studio Code. All right, here we go. Now, as you can see, I tried to mention a few files. What can you do on a Docker level? What can you do on a Kubernetes level? What can you do on a Terraform level in combination with TerraGrunt? Now, let's start with Terraform, because I mentioned that so often. I hope you're a bit confident with Terraform. So I have this very, very simple file here that basically only spins up and resource, an EC2 instance, right? And then has this security group here with all this, and then it outputs the public IT once that's done. So if you watch closely, there's a small bug in there. And well, if you work with Terraform, then the first thing you should definitely do is, well, you could use a tool called tflint to spot early mistakes in your Terraform, okay? And that, for example, tells me, well, instant time T2 mini, well, that's not supported. That's not even known, right? So I even have some problems in that code. So you can quality assure your Terraform code in advance, and also usually make sure that you kind of format that occasionally so that the formatting is all good. Now the tflint, you should integrate that into your CI pipeline, that you continuously check all the commits that well, go against your infrastructure code, for example. Many other tools are available here, right? For example, what you can do is you can use a tool called Checkoff. Simple CI tool that you can do to security check, and using static analysis, right? You don't need running infrastructure for that one. So it's real simple. Have that tool, and it will tell you, well, listen, having a AWS security group that opens that port to anyone out there, or maybe uses port 22 for SSH, is not such a good idea. Get that checked, right? So nice little open source tool. Put that into a toolbox. Put that into a CI pipeline, and quality assure that those major pitfalls, major security pitfalls in your Terraform code are not present. Of course, there are other commercial ones. You can use Snike to do pretty much exactly the same check, for example. So have the CLI installed and let it check, and then it will tell you, well, there are 5 found issues with that Terraform code. Now this is all static analysis. But of course, you can also do kind of, dynamic testing. And in a Terraform world or in a TerraGrunt world, there is this fancy test framework called TerraTest. Comes from the TerraGrunt people. And that's really neat. All you need to be able to is, you need to be able to write some Go code. And if you have a look at this Go code, there's not much code you have to write. So basically what you do is you take your Terraform definition, you need an AWS account, so this is an integration test basically, and all you do here as code in code is, do the init and apply that you've usually done manually, do that in code. Then check the outputs, maybe do some additional tests. If everything works, you do Terraform destroy at the end of the test, and you know that your Terraform definition does exactly what you expect it to do. So with a few tools available in a few frameworks, you can quality assure your Terraform code on a continuous basis as part of your CI process. Have a look at TerraGrunt. I told you that this the structure and the conceptual architecture will manifest itself ideally on the source code level. So let's say I have a dev account, I operate in the region EU Central 1, and in here I have a dev environment, and maybe in here I have an int environment. Now I have modules in here, and this is what I kind of call dependency injection on an infrastructure code level. What I have here is this TerraGrunt file, and all I do here is I reference a module and I instantiate that module. So I tell it, hey, have a look at this source, check out the custom VPC module in version 1.0, and then provide it the following inputs to parameterize that module. So what you do here now is the module definition and the module structural definition lives in a separate Git repository. Okay, so that is just the structure, and what happens here in the TerraGrunt definition is the instantiation of that module. Now let's say I gave you the example with the Aurora database. I want networking. So networking is like the bottom layer. On top of the networking layer, I want to sit maybe my persistence layer. I need an Aurora database. So for the Aurora database to work, what is required is kind of a reference to the networking module, because the Aurora database needs to know which subnets do I need to work on, what's the VPC ID, and so on. And that is also really neat. You can model those dependencies with TerraGrunt. You tell it, this Aurora database module has a dependency on the networking module, and if it's not instantiated yet, do that first and then run that. And then with this syntax here, I can reference the outputs of the dependency module and then provide those outputs as inputs to this module here. So TerraGrunt takes care of, plumbing and wiring all your Terraform modules in the right order and providing the right inputs and outputs, to all the individual modules. So using that way, you can pretty much spin up a whole environment in one go with one TerraGrunt apply, or apply all in that case. So that's really neat. Now, what can you do on the other levels? Well, Kubernetes, for example. Well, same here. Many tools available. Have a look at a tool called KubeVal or KubeScore that will kind of tell you how good is your Kubernetes definition. So let's go in here and do that, right? And all that KubeScore does, it's basically, checking your code against best practices continuously. We can have that in your CI pipeline as well. And then it tells you, you should specify container resources, the security context is not good, you should specify probes, and all those best practices that are out there, how you should write those manifests, they are checked against the KubeScore. Said before, there are many tools out there. Pick and choose the one. Some are commercial, some are open source. Pick the ones that fit your workflow best. So you have Polaris, you may have Snike, for example, as well. And don't repeat yourself, of course, when you talk about Kubernetes YAML, please think about, getting those redundancies out of your Kubernetes YAML. Have a look at Customize, or maybe write some Helm charts. Please don't copy paste the same Kubernetes YAMLs for all your environments. I mean, this is kind of the worst thing you can do, the worst maximum of redundancy. And last but not least, guess what? You can also use TerraTest to, well, continuously apply in code using a Go unit test. Well, you say kubectl apply of those manifests. You then wait until everything is deployed. You do some checks. And finally, if everything works, you say kubectl delete. So again, here for Kubernetes, pretty simple to get things checked properly and get things tested and validated continuously so that you end up with clean Kubernetes manifest files. Same here for Docker. You can have a Docker file linter. You can use Snike again. You can use a tool called container structure test to actually check that the expectations you have on your Docker image, that certain files are in there and the files have certain contents. You can use container structure tests, for example, right? So where do we have that? Here's the structure test. So you can check file contents. You can check if the commands are working or the file existing tests. So make those changes. It's not much work. It's not hard to do these things, right? The tools are out there. You just need to use them. All right, time is progressing. Let's go back to the slides quickly and go here. Where's my OBS? Here we say Google Chrome. So that is the demo slides. Now maybe one final word. I don't want to start this flame war with this declarative with imperative, but recently I came across a tool called Pulumi, for example, and maybe that is the future for some teams, because this kind of gives you the possibility to express your infrastructure code not in a declarative way, but rather in the programming language you're most confident with. So if you write your standard code in Go, well, you can also express your infrastructure code in Go, or maybe in TypeScript or Python or whatever. So make sure that after the talk you have a look at those new kids on the block, those imperative approaches to infrastructure code. It's definitely worth a look at. This is what Kubernetes YAML, for example, looks in TypeScript if you would write it with Pulumi. So that should give you a rough idea. And now you can apply all those CI tools you have anyway, all the tools your team is most confident with anyway, and you can unit test that stuff. Okay, then that's it for this talk. Slightly overdue, 37 minutes. I hope you took something out of this talk. I hope you agree that it's important to write clean code on all levels, on the business application code level, but also on the infrastructure code level, and that it's not much work to get it checked continuously and to write good quality infrastructure as code. Okay, enjoy the rest of the conference. Drop by our QA booth if you want to have a chat with me, and have a good day. Bye.